We're going to talk about fractions, decimals, percents, and a few other little facts along the way. Again, episode 1, we're going to just focus on some basic definitions of what a fraction is. So, mathematically, a lot of times we hear this word numerator, denominator, or we may hear the term part over whole, or we may see it simply as the number of pieces selected over the total number of pieces. So let's take a look at 3/4 as an example. Again, 3/4 should create an image for you. For me, you kind of see I'm stuck on the rectangle. We'll model this with the rectangle. So I have this whole rectangle, if you will. One rectangle, one whole. What I'm allowed to do with 3/4 is, the 4 is what I kind of focus on to begin with. Because again, that means divide by 4, or divide into 4 parts. So I have to divide into 4 parts. And you have to be very careful that it has to be 4 equal parts. Otherwise, the meaning is lost. So when you divide it, it has to be in 4 equal pieces here. The 3 kind of tells me how to count. And that's where the numerate kind of comes in. So numerate kind of implies counting. So I got to count out 3 of these guys. So what I need to do is shade in 3 of these pieces. So I shade in 1/4, 2/4, 3/4. So again, following the concept here, the number of pieces selected was 3. The total number of pieces was 1, 2, 3, 4 pieces. So there's where 3/4 is coming from. Again, denominator kind of describes what type of fraction I'm dealing with. So in this case, since I have a 4 here, I'm dealing with fourths. Another way we look at this is 3/4 could also mean simply 1/4 plus 1/4 plus 1/4. So 3/1/4 literally means 3/1/4, which means I can also write that as a multiplication problem, 3 times 1/4. So these all mean the same thing. This is the simplest way to write it. Just write it as 3/4. Now to apply 3/4, suppose I want to do 3/4 of $20. If I want to do 3/4 of $20, I can use a rectangle as an abstract way of modeling $20. So we'll just call this $20. 3/4 of $20 means to cut it into 4 pieces. So I can half it and half each half. That'll give me 4 equal pieces. 3/4 means to shade in 3 of the 4 pieces. So from an application point of view, what I just did is divided 20 into 4 equal pieces. If I do, each piece has to be $5. But I'm only getting to shade 3 of those 4 pieces. I've only selected 3 of those guys. So I can see that 5 plus 5 plus 5 is 15. So 3/4 of $20 would actually be $15. So this could actually model out as a picture. Another example we'll look at is 5/5. Again, 5/5, from a picture point of view, the bottom 5 tells me to divide it into 5 equal pieces. So there's 1, 2, 3, 4, 5 equal pieces. The top number tells me how many to take. So I'm going to take 1/5, 2/5, 3/5, 4/5, and 5/5. So I'm going to shade in all these guys. So in other words, I've taken all 5 pieces. So 5/5 is really the same thing as taking the whole thing. So 5/5 is the same thing as 1 whole. Because you can see that I've taken all of it. So that means I've taken 1 whole, 1 rectangle in this case. Again, 5/5 could mean 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. So 1, 2, 3, 4, 5 1/5, which means this is also the same thing as 5 1/5. Now, the easiest way to interpret that is simply, 5/5 is the easiest way, or write that simply as 1. But this will be all different ways to model that problem. My last example, I want to look at 8/5. 8/5 is called an improper fraction because this fraction is actually over 1. So if I look at this problem, the 5 tells me to cut into 5 equal pieces. But I got to take 8 pieces. But notice how there's only 5 pieces in this whole. So that only represents 5/5. To have 8/5, I got to pull out another rectangle, cut it into 5 pieces. But this time, since I've already got 5 shaded, to get 8, I just need to shade 3 more. So that would represent 8/5, because each one of these smaller shapes is 1/5. So I have 8/5. You also can look at this as 1 plus 3/5, which we can put together and write that as 1 and 3/5. 1 and 3/5 is described as a mixed number. So 8/5 could also mean 1 and 3/5. Another way to model this, 8/5 means 1/5 plus 1/5, and write that down 8 times. So 8/5 literally means to write down 1/5 8 times. 1, 2, 3, 4, 5, 6, 7, 8/5. But we also know that I can group this by 5s, because we know that for every 5/5 we have a whole. So 1/5, 2/5, 3/5, 4/5, 5/5. So notice how this would represent 5/5 plus an additional 3/5, which we could also write that as 1 and 3/5. So there's a couple of things we can do with fractions. A good way to start with fractions is just try to draw me some pictures. Also notice that some fractions can be considered over 1, and we get what we call mixed numbers. Stay tuned for our next lesson.